The process of transforming this 1/25th scale 1969 Chevrolet Chevelle SS plastic model kit from Chevelle into a fully functional radio-controlled vehicle continues. In today's video, I tackled what I anticipated would be one of the more difficult steps of this project, though with a bit of patience and some planning, it ended up working out about as smoothly as I could have hoped for. Join me as I showcase how I've gotten this mini muscle car one step closer to being ready to tear up the streets. Hello everyone and welcome back. The Chevelle has returned to the bench as I'm once again making some progress on this build in an attempt to make this my most lifelike and detailed RC car conversion so far. The premise is pretty simple. Take this fantastic 1/25th scale model kit from Chevelle and transform it into a fully functional RC vehicle that can actually be driven around. To maintain as high a level of detail and lifelike realism as possible, though, has required quite a bit of custom design work and 3D printing in order to create my own components that not only function like the real thing, but also look similar too. So far, I've utilized one of our MA10 rear axle assemblies, which is mounted to the frame using the factory-style 4-link and coil spring rear suspension. It both looks and functions perfectly, with it even fitting around the exhaust pieces included in the model kit. Then after I got the rear end squared away, I moved on to the front, with some custom designed and 3D printed control arms, which I again did my best to somewhat replicate the shape and appearance of the real thing as best as I could, but of course they also have to be able to function as well. It definitely took some effort to make sure everything was lined up correctly and that I was making as few modifications to the frame piece as possible, but eventually I ended up with what you're seeing here. I'm really happy with how this car is turning out, and especially once I get everything painted, I think these custom-made components are going to blend right in and look like they came from the factory. Of course, if you're interested in seeing all of the progress that I've made on this project so far, I'll have the link to the video playlist down below in the description if you'd like to check out those prior updates. These types of projects can certainly present some challenges, but so far it's been relatively simple and straightforward, in part thanks to some 3D scans that I captured during the very beginning of this project, which certainly aided when designing all of these custom parts. What I believe will be one of the last major hurdles for this project is figuring out the steering. Of course, like with everything else, I want to try and match the design and appearance of what you'd see on the real car as closely as possible. Without a doubt though, some deviations will need to be made in order to ensure there's a sufficient amount of strength with all of these components. And I'll need to shoehorn in the steering servo, which, although small, is not exactly the same size and shape as what the steering box would be on the real car. Naturally, there's always going to be some sacrifice when doing these types of model car conversions, but of course the less it detracts from the appearance, the better. I already had a pretty good idea in my head of how everything for the steering was going to work, but I actually started out with the, I guess we'll say, somewhat easier task of getting all of these tiny electronics wired and ready to go. When lifelike realism is a priority, you'll want to choose some tiny electronics, which is exactly what I have here today. This DAS Micro, ESC, and FlySky compatible receiver are just about as small as it gets, and are actually intended for even smaller scale projects than this 1/25th scale Chevelle that I'm building here. But as long as high-speed performance is not a priority, they'll work just fine for this particular application. Now this tiny ESC that I have here is only compatible with 1S LiPo batteries, so definitely keep that in mind. You can certainly get 1S batteries even smaller than this one that I'm using here, but there'll be enough room for this 260 mAh battery in the trunk, so really no need for me to go smaller than this when it comes to choosing the battery. Once again, I'll be using an N20 size motor and gear assembly, as they provide plenty of torque and a sufficient amount of speed for a highly detailed model. And of course, most importantly, their small size makes them easy to fit on the frame and cover with the 396 big block engine pieces included in this model kit. I'll have links to all of these components that I'm using here, along with all of the STL files for the 3D printed components over on our Patreon, which I'll have linked below in the description for anyone crazy enough to want to do a similar project to this. Of course, these components here are not simply plug and play and do require you to solder all of the connections yourself. I'm using some 32 AWG magnet wire to make all of these connections, as it's nice and thin, making it easy to tuck out of the way. From here, it's just a matter of having a good soldering iron with a good tip and not drinking too much caffeine, basically making all of these tiny connections as secure as possible. Earlier, I did spend some time deciding where I wanted to mount each of these components. The motor and steering servo will need to be placed under the hood, with everything else being placed in the trunk, as there's plenty of room back there, and that'll keep everything out of sight on the finished model. If I can figure out a way to make the body removable without too much trouble, that'll be great for allowing access to the battery in the rear, but another option would be to make the trunk functional so it can simply be opened up to change the battery. I'll figure that out in the future, but for now I simply got everything soldered together, making sure that there is enough length of wire for the components that are going to be under the hood, while not having so much excess to where everything is just going to be a total rat's nest. Something to think about when building these types of RC cars is to try and make things as serviceable as possible. I talked about this more in the previous video that I posted here on the channel. I ended up having to resolder a connection on this 39 Chevy Coupe that I built previously using the same components that I'm using here for the Chevelle. Because of the way that I laid everything out on that chassis, it wasn't too difficult to gain access and resolder that connection. Obviously, I'd like to do something similar here if I can, making the electronics and all of these components as easy to remove or work on as possible. This of course can sometimes be easier said than done though, especially when you're trying to maintain a high level of accuracy and detail, but is always something to think about. You can see this additional connector right here. This is where I plan to plug in the functional lights that I'll be adding to the body. This connector will allow the body to be fully separated from the chassis. The final step after getting everything soldered together was to power it up and make sure everything works. Fortunately, it's all working exactly as it's supposed to, so these electronics are ready to be installed on the car when that time comes. Right now though, I'm turning my attention to the steering. In the previous update in the series, I designed some simple steering components consisting of the tie rod ends and center link. As with anything else, I tried to make these components as close to the correct size and shape that the real parts would be in 1/25th scale, matching the appearance of the non-functional parts included in this plastic model kit. But this is yet again one of those areas where some compromise has had to be made in order to ensure there's a sufficient amount of strength and durability. Now, by no means is this car going to be a basher, but at the same time, I don't want this area to be too prone to failure. I SLA 3D printed these parts using resin, and as you'll see once I get everything put together, I think I struck a pretty good compromise here. 1x10mm steel dowel pins are used to connect the tie rod ends, while M1 size hardware and O-rings were used to connect the tie rods to the center link and steering knuckles. This hardware was tightened enough to where everything is secured and ideally there's not too much slop, but of course not so tight to where things can't move like they're supposed to. I found that adding in those O-rings in some spots definitely helped with this. Certainly some tiny hardware to deal with here. As always, it's a very good idea to be working over a magnetic mat, but eventually this was what I ended up with. I was very happy with how it was looking so far, but it was clear that some minor alterations to the frame were going to be required. As I said, I want to make as few modifications to the frame as possible, however it was clear with this particular setup that a little bit of massaging was going to be necessary in a couple spots. On both ends of the frame, the center link is going to need some additional room to move as far as it needs to go to steer. Before I made any modifications though, I also wanted to figure out exactly where and how I was going to secure the steering servo to the frame. Ideally, I sort of want it to be placed near where the core support would be, and I'll have to try and tuck it out of the way as best I can, but of course the spline on the servo has to be in a fairly specific location so it aligns with the center link. What I eventually came up with was I cut a small piece of styrene which I can glue to this upper portion of the frame. A screw is used to secure the one side of the servo, and I'm not sure I'll even bother making another mount on the opposite side, as again this car isn't a basher, so I think one screw holding it on might be sufficient. But to ensure I didn't damage anything while modifying the frame, I removed the entire front suspension assembly and did a little bit of grinding with a rotary tool. Not exactly ideal to have to do this, but not too terribly unsightly. It really was necessary though to allow more room for the center link to move from side to side. At this point, I went ahead and glued the servo into place, which just leaves the idler arm as the final component of the steering setup to add. I measured the distance from the center of the steering servo spline to the mounting hole I'm using for the center link, and then designed and 3D printed a piece that I'll be using for the idler arm. Initially, I printed two thinking that I could have a spare, but what I ended up doing with the second one was trimming off the end and gluing it to the frame to serve as the mount for the opposite end. And while certainly tiny and a little bit difficult to get positioned exactly where I wanted, this ended up working out really well, as you can see here. I definitely made sure to layer on the glue where it mounts to the frame, so hopefully that stays secured for the life of the vehicle, as it has to be positioned somewhat accurately so the center link isn't at too bad of an angle. But as you could see, everything is working just as it should, with it being able to steer as sharp as you'd expect, and the steering components aren't coming into contact with anything through their entire range of movement, nor when the suspension is fully extended or compressed. Overall, a really nice setup here, and I'm happy to see it turned out as well as it did. Of course, some modifications to the under the hood area will be necessary in order to accommodate the steering servo, but hopefully no major sacrifices will need to be made, as there's only so much that I can do to hide that servo, as it really wouldn't be practical to position it any other place than where it is here. Of course, more on that process in a future video. For now though, I'm really happy with where the car is at currently. Like I said, I knew building the steering system for this car would have the potential to be a bit of a challenge, but what I have here is probably about as good as I could have hoped for. These types of projects aren't just something that you can slap together in a weekend, and I've been really taking my time with this Chevelle, and I think it shows in the results that I've been able to achieve so far. With that said, I think it should be pretty smooth sailing from here. Really the only thing left that pertains to the functionality of this vehicle is getting the motor mounted and the driveshaft installed. At that point, the car will be fully functional, but I have a feeling that there's going to be a fair bit of work needed under the hood to get the engine bay looking as lifelike as possible, while obviously housing that N20 motor and steering servo. I'd also like to add some functional lights to this vehicle, which is always fun, and by fun I mean a bit of a pain, but it does look cool on the finished car. But this is where I'm at currently with this project. I hope you all enjoyed this little update, and it's maybe inspired some of you to try something similar. Or maybe it's inspired you to just stick with the 10 scale stuff. I could certainly understand. As always, a huge thanks to all of our Patreon and channel members for helping to make these videos possible. Like I said earlier, all of the STL files for the 3D printed parts I designed for this project are available on our Patreon, along with many other universal chassis designs which will fit a variety of different projects, all of which I've showcased here on the channel previously. But that's all I've got for today's video. Thanks as always to all of you for watching, and I will see you next time.